Hello students, welcome to my YouTube channel Rapid Chemistry. Today here I am Ranjan with you to discuss a very important chapter of class 10 ICSE, and that is mole concept and stoichiometry. Mole concept and stoichiometry. And here I am discussing the chapter taking the reference of that book Concise Chemistry of Selena publication. Okay. And the chapter having generally 4 units. And the very first unit here is Gay-Lussac's law and Avogadros law. Okay, Gay-Lussac's law and Avogadros law. The chapter mole concept and stoichiometry is mainly dealing with the numericals. Okay, actually you have to do lots of numericals, different kind of numericals here. So on the very first unit, as it is there, Gay-Lussac's law and Avogadros law, we have to know simple information and all those which we have already got earlier, like Boyle's law P1 V1 P2 V2 at constant temperature, like Charles' law, that is V1 by T1 equals to V2 by T2, the pressure remaining constant, and the equation, that is the combination of Boyle's law and Charles' law, and P1 V1 by T1 P2 V2 by T2. Okay, where all these three, pressure, volume and temperatures, are variable. And next we have to study standard temperature and pressure, STP. So we are familiar with the term STP or NTP, and what does actually it mean? The standard values chosen are 0 degree centigrade or 273 Kelvin for temperature and 1 atmospheric pressure or 760 millimeter or 76 centimeter of mercury of pressure for considering generally gaseous system. Okay, so these are the STP. So at STP we have to remember the standard temperature and pressure. Okay, at the next we must have to go through the temperature scale, and generally in SI system, you know, the temperature scale we are using Kelvin scale, and where the absolute zero temperature is taken as minus 273 degrees centigrade. Minus 273 degrees centigrade. Okay, and after that each degree is calculated as the same as that of in centigrade scale. So as the name of the chapter is there at the stoichiometry, and what stoichiometry is all about, and here it has been written, just read out and try to explore. Okay, the stoichiometry measures quantitative relationship and is used to determine the amount of products and reactants and that are produced or needed in a given reaction. Got it? So describing the quantitative relationship among substances as they participate in chemical reactions is known as reaction stoichiometry. Okay, so we will discuss all these in taking lots of examples here. Now we will study Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volume was given in the year of 1805. Okay, 1805, and that is all about very simple. So before we go through the statement, try to understand the simple example as given here. Say ammonia is produced from nitrogen and hydrogen. Okay, and if you go through the reaction here, and it is a balanced reaction, and the ratio of nitrogen, hydrogen and ammonia, and you know 1:3:2, and that is coming from there the stoichiometric terms just before the symbols given in the reactants and the products. Okay, similarly for another reaction, formation of carbon dioxide has been shown from the constituent carbon monoxide and oxygen, and they are all in the gaseous phase and maintaining the ratio, volume ratio 2:1:2. Okay, 2:1:2. Okay, and that ratio is generally maintained and taking in that all the substances are under same temperature and pressure. Okay, now we can simply say that from 1 liter of nitrogen and 3 liter of hydrogen and the 2 liter of ammonias are produced, or the unit you may change, 1 ml and 3 ml react to form 2 ml. Okay, like that. That means ratio is to be maintained. And now if say there is a question that the amount of hydrogen is 6 liter, then what would be the ammonia? So simply we can find out, because that value will change proportionately. Okay, so for if it is 3, then it is 2. So if it is 6, then what it would be? So we can find out, and that is all about Gay-Lussac's law. Now let's explore the Gay-Lussac's law. Gay-Lussac's law of combining volume. When gases react, as we have seen, gases react, like say nitrogen and hydrogen reacts to produce product. Okay, so when gases react, they do so in volumes which bear a simple ratio to one another. Okay, and to the volume of the gaseous product, provided that all the volumes are measured at the same temperature and pressure. Okay, so Gay-Lussac's law is valid only for gases. The volume of solids and liquids are considered to be 0. So the ratio, that means the gases react, nitrogen and hydrogen reacting, and their ratio is a small whole number. Okay, and if the product is also gaseous, and it's the volume of that one also maintaining a simple ratio with that one. So from the Gay-Lussac's law, now we'll try to explore some numericals as given here. So let's look at the very first one here. What volume of oxygen would be required to burn completely 200 ml of acetylene, and what would be the volume of carbon dioxide formed? So here it has been written, and so at first you have to write the reaction. So reaction, so few clues I would like to share with you for the reaction. So acetylene, you have to know the formula, acetylene C2H2, and that one under complete combustion with oxygen always produce CO2 and water. Okay, and you have to balance it for doing the numerical, and it has been balanced. So whatever the hydrocarbon be, always try to keep in mind here that the products must be CO2 and water, nothing else. So their volume ratio has been written. Now what is written? What volume of oxygen would be required to burn completely 200 ml of acetylene? So the here problem is in between acetylene and oxygen. 200 ml of acetylene given, and you have to find out the volume of oxygen. So if it is 2 volume, then it is 5. If it is 200, and how much it would be? Okay, so it is 2 and it is 5, and if it is 200, how much it would be? I can solve that numerical in different way, and say at first you have to write the balanced reaction, and from the reaction and you can write the volume ratio. If it is 2, it is 5 and 4, and here 2. So as from the question we got here the relation is between acetylene and oxygen, and it is written 200 ml. Okay, so it is 200 ml, then what it would be? So you can do simply like this, say acetylene and oxygen. So here I can write, say C2H2 is to oxygen, and its ratio 2 is to 5. Okay, and the C2H2 value that is given, and that is 200, and say the amount of oxygen I took X. Okay, so it would be 2 is to 5. Now just try to solve the very simple equation here. 200 by X equals to 2 by 5. So therefore 2x equals to 1000, and therefore X would be 500. So that would be the amount of oxygen required. So you can do like this. Okay, so but here in your book it has been done differently. It has been done differently, so you can choose any one, and which seems to be easier to you. So up to that one you must have to do, but here it has been done like this. Okay, can you see? So 500, and we also got 500 taking the ratio. Okay, so whatever process suits you, you can follow. Okay, similarly for the second part we can do. So if it is 200 ml, what would be the volume of carbon dioxide? So if it is 2 volume, it is 4. So if it is 200, definitely it would be 400. Okay, so taking unitary method or ratio method, you can do it. Okay, let's move to the very second one. So example number 2 here. If 6 liter of hydrogen and 5.6 liter of chlorine are mixed and exploded, what will be the composition of the volume of the resulting gaseous mixture? Okay, and you have to name the limiting reagent also here. Okay, so the reaction here would be hydrogen and chlorine simple reaction, and it will form HCl or hydrogen chloride. Okay, in the gaseous form, and the volume ratio 1:1:2. So if it is 1 volume, and then it would be 2. Okay, And now here, and if you observe, the data is given for 6 liter of hydrogen and 5.6 liter of chlorine are mixed. Now try to understand the amount of hydrogen and chlorine required for the reaction would be same, 1:1. Okay, but here 5.6 liter of chlorine is there, but hydrogen is given and 6 liter. So it is very much clear to you that is the total hydrogen will not be used up here. The 5.6 liter of chlorine completely used up, and the rest with 5.6 liter of hydrogen, but some amount of hydrogen will be left after the reaction, and that amount has been written here. Can you see? 6 minus 5.6, so that would be 0.4 liter of hydrogen that will remain unreacted. Okay, so the amount of HCl, it will produce just double of that their ratio. So here the 5.6 liter of 5.6 liter of chlorine is there, so the double of that one, that means 5.6 into 2, 11.2. And why it is double, can you understand? And here, so volume ratio 1:2. If it is 1, it is 2. Okay, so volume of HCl formed will be 11.2 liter. So in that process, the chlorine is completely used up, but hydrogen and having a small extra amount, and that is 0.4 liter. So here go through the answer. 11.2 liter of HCl and the 0.4 liter of residual hydrogen is there, and the chlorine is the limiting reagent here. So what is the limiting reagent? Limiting reagent means whenever 2 or more reactants are there, okay, the reactant which is completely used up, that is the limiting reagent. So you just go through the note point here as written. The reactant which is completely used up in a reaction is known as limiting reagent. Okay, got it. Now let's move to the very next one, example number 3 here, and the question goes, what volume of propane is burned for every 100 semi-cube of oxygen in the reaction? So at the very first, what you have to do, you have to write the reaction. Propane burns in oxygen, propane burns in oxygen, and I am writing here reactions and try to understand the reaction. Propane means C3H8 reacting with oxygen, and the product will always be CO2 and water vapor, as I have said. Okay, now you have to balance, and how to balance? C3 and put 3 here, okay, and H8 put 4 here. Okay, so carbon and hydrogen, it remains same in both and left and right, and the total amount of oxygen on the right, 3 into 2 6 and 4 10, so just write 5. So now that is the balanced equation you got for propane. So from that equation, and you can say the volume ratio, and if it is 1 volume, it would be 5 volume, it would be 3 volume. Okay, and that is water, and its volume is not needed because that is in the liquid state. Okay, if it is in the gaseous state, then its volume is to be considered. Now let's see the question as it is there, and that's how the reaction came as I have shown here. Okay, so now what volume of propane is burned for every 100 semi-cube of oxygen? So if it is 100, then it would be how much? Okay, if oxygen is 100, what volume of propane is burned and for 100 semi-cube of oxygen? That means, and here, that means that is here, if it is 100, then semi-cube, what would be the volume of propane? So have the ratio, and here, and we can write the ratio. C3H8 is to O2, and their ratio equals to 1:5. Okay, so C3H8, the ratio, the amount of that one have to find out and take it as X, and for O2 it is written 100, it equals to 1:5. So we have to find out the value of X. So X by 100 equals to 1/5. So, and here the X is coming to be 20 semi-cube. Okay, X would be 20 semi-cube. So same thing here is there, and they did in different way, but the result is same. So you can choose any one process as you wish. Okay, another important one here, 20 ml of hydrogen and 10 ml of carbon monoxide. Okay, and 20 ml of oxygen are exploded. So what are in idiometer? Idiometer is a very small tube made up of glass, where generally these reactions can be carried out. So 20 ml hydrogen, 10 ml carbon monoxide, 20 ml oxygen. So what are the reactants here? And there are 3 reactants, and what will be the volume and the composition of the mixture of gases after cooling to room temperature. After cooling to room temperature, that means, and when it is cooling to room temperature, if there is any water vapor, that must be taken into liquid state. So at the very first we have to write the reaction. So hydrogen is there, oxygen is there, and carbon monoxide are there. So there would be possible reactions, 2 reactions there will be. So hydrogen and oxygen, there will be H2O, and another reaction, carbon monoxide and oxygen react to form carbon dioxide. Okay. So and here in both the reactions, oxygen is common. Oxygen is common. That means oxygen is used twice, in the first reaction and also in the second reaction. So, and if you observe here, if 2 volume, it is 1. So if it is 20, so definitely amount of oxygen would be 10. And for the second reaction, and if the ratio is 2:1 again, so if it is 2, it would be 1. So if it is 10 as given in the question here, so it would be 5. So to consume total 20 ml of hydrogen, 20 ml of carbon monoxide, amount of oxygen spent 10 plus 5, that would be 15 ml, and that's why it is written total volume of oxygen used 15 ml. So volume of, but we have oxygen 20 ml, so 5 ml of oxygen is unreacted. Okay, that is there in the extra. Okay, so volume of carbon dioxide form, and that must be 10 ml here. Okay, so total volume of gases would be 15 ml. And how? So carbon dioxide volume 10 ml, and the extra 5 ml of oxygen is there, that one. And as in the question as it is written, so volume is to be considered after cooling to room temperature. That's why the water volume is to be taken as nil, because that is no more in the gaseous phase. So hopefully you got it, and the answer with the explanation is given here nicely. Total volume of the gaseous mixture after cooling to room temperature would be 15 ml, containing 5 ml of oxygen and 10 ml of carbon dioxide. So these are the different kind of numericals I have shown here from the Gay-Lussac's law. Okay, now let's move to Avogadro's law. Now you will try to solve the numericals from the Gay-Lussac's law, and if you have any problem, and definitely you will share with me. Let's move to Avogadro's law here. And the Amedeo Avogadro, the Italian scientist, in the year of 1811, more than 200 years back, gave a law, and that is equal volume of all gases under similar condition of temperature and pressure contain the same number of molecules. And what does it mean? If the same volume of different gases are taken, that is O2, CO2, N2, if their volume is taken same under same condition of temperature and pressure, and the number of molecule of different gases would be same. Okay. So the explanation here is written and very clearly and neatly. Okay, you must go through here once. So now our definition of atom and molecules, and these are there in the class 7-8 level, and I hope you know all these, but still once more just go through. Okay, and the atomicity, and you know what is atomicity? Atomicity is the number of atoms in a molecule of an element is called its atomicity. So atomicity of the different substances can be different as given here, and try to observe here one by one. Okay, so the very first one here is monoatomic. Monoatomic, generally inert gas like helium, neon, argon. Diatomic. Diatomic molecules is composed of 2 similar atoms like H2, O2, Cl2, N2. These are the diatomic. And the triatomic molecule is composed of 3 similar atoms, and that would be O3. And the tetraatomic molecule is composed of 4 similar atoms, and that is phosphorus. Octaatomic is there, and that is sulfur. Okay, so these are the atomicity. So molecules made up of some type of atoms are homoatomic molecules. That means same atoms are there, P, okay, O, etc. While molecules made up of different type of atoms are heteroatomic molecules like HCl and ammonia. Okay, from Avogadro's law we must have to go through important numericals here written, very easy one. and what is written, let's see. If 50 cc of a gas A contain Y molecules, how many molecules of gas B will present in 25 cc? Under same condition means you know that is Avogadros law, and where it states the equal volume of all the gases will having same equal number of molecules. So if 50 cc having Y molecule for A, so similarly for B would also 50 cc will have Y molecule. So 25 cc it would be just half of that, that is Y by 2. Okay, and the same is done here. Okay, hopefully you got it. So now you have to go through the exercise 5a. Exercise 5a is there in your book. Okay, that is the Gay-Lussac's law and Avogadro's law, and just to go through these numericals, and that one came in the 2017. Okay, so and that one came in the 2018. Okay, that one. So just try to solve. Okay, and if it is not done by yourself, then I will definitely help you. Okay, at first try yourself.